speaker, we have Kiruthiga Balendran. Kiruthiga is a skilled data engineer with more than 4 years of experience. As an associate technical lead at Cisco Labs Technologies, she oversees her team in designing and developing ETLs, analyzing and validating data for reporting purposes. Kiruthiga has earned a bachelor's degrees in both software engineering from SLIIT and Physical Science from the University of Colombo. Currently, she is pursuing an MSc in computer science with a focus on data science, engineering, and analytics. She is a data enthusiast who enjoys creating, managing, and testing data infrastructures. So with great pleasure, I would now invite Kiruthiga Balendran for the second lightning talk. She'll be speaking on the topic Data Warehousing Demystified, Understanding the Fundamentals for Better Business Intelligence. Over to you.
Hello. Thank you, Samya. Let me share my screen. Hi, a very good morning to all of you. So today I'm here to talk on data warehousing demystified. So this topic is not directly about data science. As Dinusha said, so data engineers also needed to bring all the data to extract from the sources so that the data scientists can extract, can analyze, and they can produce the reports. So today I'm going to brief about the data warehousing basics so that how it can be helpful for the better business intelligence. So what is data warehousing? Data warehousing refers to the process of collecting, organizing, storing large volumes of structured and unstructured data where we can collect from various sources and can load into a centralized repository. So the purpose of this data warehousing is to provide unified and integrated view of an organization's data so it can make it easier to analyze, report, and extract insights. So if we see the difference between the normal data warehouse and the traditional databases, so the traditional databases are designed for transactional processing and they focus on the efficient storage and we can retrieve of data like day-to-day operational activities. But on the other hand, if you check the data warehouse, it is specifically designed for analytical processing and it aims to support complex queries, reporting, and data analysis. So there are some key components in the data warehousing where we have data extraction, data transformation, data loading, data modeling, querying, and analysis. So why we need data warehousing? It has a centralized data storage that allows business to consolidate different sources into a single data repository. And it helps to improve data analysis and real-time and historical analysis. So by integrating data from diverse sources, businesses can build an comprehensive dashboards and that help to visualization. By using the data warehouses, they can handle large volumes of data and they can support complex and analytical queries efficiently. So these data warehouses, they facilitate effective data governance by providing like centralized platform for data cleansing, quality management, and security controls. With this data warehousing, we can integrate multiple advanced technologies like machine learning, artificial intelligence, and predictive analytics. So here we will see the architecture of the data warehouse. I'll explain it in simple words. So here we have like 4 components. So the first one is the data extraction, where we extract data from various sources like operating systems, ERP systems, transactional databases, spreadsheets, and there are other external sources also. So once the data is extracted, we have to transform that data. So we are transforming that data because then only it can be consistent and it will be suitable for the analysis. So in this transformation process, like we can do data cleansing, aggregating, integration, and we can apply lots of calculations also. And some business rules also can be applied so that this transformed data can be loaded to the data warehouse. So in the data loading part, we have where we transform the data to the data warehouse. So after we transform the data and we load it to the warehouse, in the warehouse, it is organized in an efficient way. And there are indexes that are used to retrieve the data. So this loading can be happen in batch mode or it can be a real time. So it depends on the business requirements. So this data warehouse also employs a specific data model. Either it can be a star schema or a snowflake schema. So I'll explain about these models in the next slide. Finally, we have the component called querying and analysis part. So here the users can query the data warehouse and they can extract data and use it for their analytics and any querying purposes. So there are different tools that they can use. So we will check those tools as well. So when it comes to this data modeling, there are two main models, as I said. One is star schema and snowflake schema. So this star schema is also known as dimensional modeling, and we say this snowflake schema as normalized model. So in this star schema, we have a one fact table, which is surrounded by multiple dimension table. And if we take the snowflake schema, here also it's kind of the same, where we have the fact table, but this dimensional table is split into multiple other dimensional tables. So this star schema is widely used for its simplicity and query performance, and it is easy to understand also. And especially when we are going to use with large amount of data, star schema is recommended. But snowflake schema, it has got a complex structure, but it reduces data redundancy and it improves data integrity as well. So there are different data warehousing tools where we have got ETL tools, data integration platforms, reporting and analytics tools. So in these ETL tools, we extract data from the source, we do all the transformation, then we load it to the warehouse. So in addition to that ETL capabilities, in the data integration platform, we can do real-time or near real-time data integration, as well as we can do data synchronization or data replication as well. With these reporting tools, we can read the data from the data warehouse and we can provide insights, visualization, so that it can help the business to improve their business models. So even when we have these data warehousing, there are certain challenges and considerations that we need to keep in mind. So the first thing that we have got is data quality. So ensuring a data quality is crucial for an effective data warehousing, because data comes from different sources. So they will contain inconsistencies, duplicates, errors. So implementing a data cleansing and a validation process is necessary. So in that way only we can maintain an accurate and reliable data in the warehouse. So if we take data governance, so we should establish these data governance policies so that we can maintain this data integrity and security. So in this data governance, we have data ownership, access controls, data stewardship, and we also have to manage practices to ensure proper usage and privacy. If we talk about scalability, so always when designing data warehouse solution, we should keep scalability in mind, because data volumes can get high, user demands can get high. So in that cases, the infrastructure and the architecture should be capable of handling these growing data loads, and it should be able to accommodate new data sources, and it should support these increasing complexity queries. By doing this, it shouldn't degrade the performance also. So when we take security, protecting the data is a bit critical in the warehouse, because there are data breaches, sensitive data is there, cyber threats can happen. So these sensitive information should be protected. Integrating from different sources can be challenging due to differences in the data formats. And there can be different structures, different semantics. So these ETL processors need to be very carefully mapped. Transformation rules have to be applied. Error handling mechanisms should be applied. So in that way, we can ensure data consistency and compatibility. So these are the famous case studies where these data warehousing has been successfully implemented. So if you take Walmart, Amazon, Netflix, AirAsia, they have built their own data warehouses in the platform, and they have used it for the business purposes to enhance their business intelligence by analyzing customer behavior patterns, the sales transactions, the trends. So by using these things, it has helped their business to improve. So I gave a brief idea about this data warehousing. I hope you guys understood. So it is not directly like into data science, but this is also part of data science. Data engineering is also part of data science, where we provide the data to have the data scientists to build their insights and analysis. So hopefully it is helpful for you. So thank you.
Thank you for your enlightening speech, Kiruthiga. It was truly captivating and eye-opening. So now the